Christmas Eve is almost here. Santa has delivered billions of presents to kids all over the world. With so many people on the nice list this year, the trip needs to be more efficient than ever. He could use some help and has tasked us to use our fancy computers to figure out the best way to get to all of these houses and make sure that everyone gets their gifts. Santa's problem is what's known as the traveling salesman problem. It's all about finding the most efficient way to deliver to multiple locations while considering constraints like time, distance, and of course, children's bedtime. We'll not question how he knows that last one. In this video, we'll start from the ground up and show you how to solve this kind of problem using Timefold Solver, an open source AI solver for Java, Kotlin, and Python. So enough talk, let's jump in and help Santa spread some Christmas magic. All right, let's get started. In this video, I'm going to live code a simple project where we have a UI like this, where we can add some trees. So these are locations, children that Santa wants to visit. And then when we want to click the solve button, then Timefold will have to calculate the best path to visit all these children. So our goal would be to minimize the travel time. So we consider the best path, the path where Santa has to travel the least. And we have to do a couple of things for that. I've made this nice to-do list, so let's get started on that one. The project setup I actually already did. So if you look here, my project setup is already done. What I did to get there was to go to the code.quarkus.io website and select these 4 dependencies. We need the REST easy dependency to make a REST API, Jackson to do the serialization, and then 2 Timefold dependencies so that we can actually use Timefold in this situation. And then I click the generate your application. Once you've done that, you get a zip file, and then you get to have a structure similar to this. So while I did it off screen, this one is done. Next up, we need to model our domain. So modeling a problem is not that much different than trying to model it with plain Java objects, because that's what we'll initially use. So we basically need to model our classes. So I made a small class diagram here that shows the classes that we're going to make. We have a location, which is just a wrapper for the latitude, longitude coordinates. We have visits. Those are the places and children that Santa wants to visit. So they have a name and a location. And then we have the big jolly man himself. He has a home location because he has to start from somewhere, and then a list of visits. And it's this list of visits that will determine the order in which Santa will execute all these visits. So let's start making those. I'm going to quickly make a new package, domain, and then let's start making these classes. I'll start with the location. And since location is just a simple wrapper of latitude, longitude, I don't need anything special. I can make it a record. So it's a double lat, double long. So that's that. I also needed a visit because those are the location, children that Santa wants to visit. So those also can be a record. And for them, I had a string ID, I had a string name, and I had a location. And then finally, I have Santa. And Santa, we will make a regular class because when Timefold does its work, it actually will change the Santa class, changing fields in the Santa class, and you can't change records, so you can't use records when you have something that you want to change. Let me get back to that in a bit. So we will have Santa, and Santa has a private location home base, so his home where he starts from, and of course a private list of visits. There we go. So with that done, we have 3 simple pojos, but that's not enough for Timefold to do its work. We need to instruct Timefold to create this list and to modify the order in the list. So this thing is what will be called a planning variable. And in this case, we have a planning list variable. There we go. And this will indicate to Timefold, please Timefold, start inserting visits here, start shuffling them around, and then calculate the score and see what the best combination is. Now, for this annotation to work, it doesn't work on any class. It needs to be on a class that's marked as a planning entity. So a planning entity is an annotation that suggests to Timefold, hey, watch out, in this class, I want you to come change something. And what do we want Timefold to change in this class? Well, we wanted to start changing these visits. So it's pretty simple like that. So let me just create some constructors. I'll take the all one, and I'll also create the one without anything, because Timefold needs no args constructor. And just for sake of clarity, let's add the getters and setters as well. There we go. All right, with that done, I believe we have finished our domain. So we can go back to the README, and we've modeled our domain. So domain done, 3 simple classes, of which 2 could even be a record. So nothing too special going on there. All right, on our to-do list, now we need to model our constraints, because Timefold will shuffle around these visits to find the best solution, but we haven't actually shown it a way to discover what the best solution actually is. So in order to do that, we need to provide some constraints. So these are basically classes that and methods that Timefold will be running to determine a score. So let me just create a new package first, solver. And I'm going to create a new class, which will be my Santa constraint provider. And the constraint provider is something that will provide constraints. So the only method we need to implement here is to define constraints. And we will define our new constraints, because the constraint that we want to have is minimize travel time. And let's pass in the constraint factory. There. And now I can start creating our constraint. Now, a constraint is basically a little piece of business logic that the solver will trigger over and over to calculate a score. The constraint that we want to make is to minimize the travel time. In order to make a constraint, you can use the constraint factory, and the constraint factory creates a constraint stream, and the constraint stream looks a little bit like SQL when you start working with it. So let me show you. Constraint factory dot for each, sounds familiar if you're used to SQL, and we're going to say for each Santa dot class, which sounds a bit weird because there's only one Santa, unless I've sometimes seen 2 of them, so it's a possibility. So for each Santa, and then you have to say whether you want to increase the score or decrease the score. Now, usually when you want to minimize something, I prefer to penalize, so to decrease the score, but you could also reward, and that's increasing the score. But in this case, we're going to penalize long, because it's going to be a pretty big number, which will be a hard soft long score of 1 soft. So there's multiple tiers of constraint scoring. We're only going to need 1, so I'm just going to use soft for now. And I don't just want to punish every Santa and deduct 1 from the score. I want to do that based on the number of seconds that Santa has to travel between these points. So I'm going to go to Santa. Oh, thank you for the useful information. Santa. And now I will make use of a helper class, because we need to calculate Santa's driving time. So I have a driving time calculator. Driving time calculator equals driving time calculator dot get instance. And this sounds oddly specific, but that's because I've already created it, because this is a class that I didn't want to live code myself, for the simple reason that, I'll just dump it in here for a second, that it's quite lengthy and it contains math. So I'd prepared that one up front. So, but it is very convenient to have that one, because now I can do driving time calculator dot get total driving time for Santa. And let me just first give this constraint a name. So this will be minimize driving time. And it's a good thing that we have to give this constraint a name, because Timefold actually keeps track of these constraints and their name. And then afterwards, you can easily see which constraint adjusted the score in which way. So let me just have a quick look at this magic thing I copy pasted in. So they get total driving time. So this basically gets from that Santa all the visits that he has inside. That Timefold will constantly adjust. If the visits are empty, yeah, then it's no driving time. Else, we basically loop over all the visits, starting from Santa's home. And after the loop, we also calculate the driving time from the last location to Santa's home. So that gives us the total driving time in a long variable. And this long variable will be used to deduct the soft score. So what's stated here is for each Santa, deduct one soft score for each second driving time. So the more seconds Santa has to drive, the lower the score will be. All right, so that's the constraint done. As you can see, the Santa constraint provider is not used, but we can ignore that because we're using Quarkus and using the Timefold extension. This thing will be automatically loaded into CDI and we can use it later. So not to worry about that. So let's head back to our README file. With that being done, our constraints are finished. Now, I actually forgot something in my to-do list. We need to get our solution together. Gather everything in a planning solution. So far we've modeled our domain. So we have some domain classes here. We have our constraints. Well, we have one constraint, but you could easily see how you can add more here to adjust the score. We still need to gather all the available visits and all the planning entities into a planning solution. So let's make our planning solution here. I'm going to call it a Santa plan. Oh, there we go. Oh, nope. And this will be our planning solution. And this class is actually what will be fed to the solver eventually. So in here, we're going to have to make our plan, all the things that Timefold can use. So of course, when you have a Santa plan, you need a Santa. And Santa, even though he is marked as a planning entity here, so something that will be changed by the solver, we still need to explicitly state it here that this is a planning entity property, that for this specific planning solution, this is a planning entity, because you could potentially have multiple planning solutions in the same project. Next up, we also need our private list of visits. Our visits. And the visits actually have two annotations that they need. First annotation is one to indicate that these are facts, because visits will not change. Those are facts, only entities really change. So let's call this a problem fact collection property, because it is a collection. And then to make sure that Santa here can actually be assigned visits that are in the Santa plan, from here, we need to state that this list is a value range provider. So by indicating this will say, hey, Timefold, whenever you look for a visit, whenever you want to do something with visits, for example, assign it to this list, you can get it from this value range. Now, let's just quickly make a constructor out of this so that we can actually initialize this. I'll also make a no-args constructor. Yep, there we go. And since I'll be exposing this through a REST API again, let's just create getters and setters as well. There we go. There is one more thing that we can do with this planning solution, and I'll do that right now. That's to get the score of the solution. So this will be the input. We give it Santa and we give it visits, but using some, I'm guessing some reflection hackery, we can actually say that we want a planning score variable to be filled in, and Timefold Solver will fill in this variable for us afterwards. And it's a hard, soft, long score. Yeah, there we go. Score. And let's just expose this one through a getter as well. A bit of scrolling here. Yeah. So our constructor makes sense. We will add Santa and then the list of visits that we want Santa to visit. And then we have a score that will be filled in by the Timefold Solver itself. So with that being done, we have gathered everything in the planning solution. So now we're going to create our REST API. I'm just going to adjust the existing example resource. So we are going to name this Santa. We are going to do a post call. We will be producing JSON and we will be consuming JSON. And what I want to do here is to call it a path. We're going to post to Santa.plan. To post the plan makes a bit more sense to me. We will be returning the Santa plan. So that's an optimized plan. And what we will be passing in are a list of visits. So what will be passed in from the front end? So the front end that I've shown you before, it's this one. So all of these things, when I click them, they're visits. And that's what we will be sending to the backend. That will end up here. Now I can just return null for now, just to get away of the compiler issue. Now we need to make sure that we have a Santa plan to begin with. So we're going to create our Santa plan. We need a new Santa plan, there we go. But we need to pass in Santa and our visits. Now I'm going to create Santa next. And for Santa, we said that Santa has a home location. So I'm going to make a new location. And the location I'm going to choose is not just random, but it is the location of Santa's village in Rovaniemi, Finland. So let me just type this over because I'm not remembering this stuff. There we go. And the initial list of visits that Santa will visit is a new array list. So just an empty list. Because we want Timefold to fill in the list and adapt things. So here we put Santa. There we go. And now if you return Santa plan, it compiles, but it's not done because we have not introduced Timefold anywhere here yet. Now, if you return it like this, then Santa will still have the empty list of visits, so not very valuable. So we need to create a solver now. Now, we've already set up our constraint provider. We've had some domain classes and such that are annotated. So I told you, you don't have to do anything special besides just injecting a solver factory. It's a Santa plan that we have here. Solver factory. This one will be, no, this one will be injected by CDI. So we don't have to actually do anything. This will be CDI. And then we can use this solver factory to pass in the original Santa plan and have an optimized plan. So solver factory dot build solver. Oh, my bad. Build solver dot solve Santa plan. And out of this Santa plan comes a new Santa plan, but this will be the optimized plan. And this is the one that we will eventually return to the front end. There we go. That is complaining that I can inline it, so let's just inline it. So that's it. So we still need to add one configuration property because by default the solver will run forever, which is not what we want. We want to give it a limited amount of time to do its solving. So let's head to the application properties, and that is Timefold termination unimproved spend limit. But it's actually .solver. And I'm going to say that if the solution, while it's running, if the solution doesn't improve, if it doesn't improve for 3 seconds, then I want to stop the solving process. So with that being done, I think we're kind of done with the exposing the REST API. Now we just need to visualize it, and kind of similar to the difficult calculation, I'm not a big front-end buff, so I'm just going to go here and copy paste the front end that I prepared, because this is not a front end presentation. Let me just make sure that there's nothing wrong here. Yep, it messed up the import now. No big deal. Okay, so that should be done. I'll make sure that the front end ends up in a repository so you can check it out later. And then we're just going to start Quarkus. Yes, that should be about done. Oh, a bit too soon. Oh, there we go. So I'm going to add a few visits here by clicking the UI. Then I'm going to click the solve button. I'll have a quick looky what this thing is doing. You can see that Timefold Solver has been triggered. It has found a problem scale of 10 to the 12th power. And what it is doing, it's finding the best score. So the best score it's found so far is 1,983 soft score. So that's seconds. And this is a thing you should keep an eye on. The move evaluation speed is basically how fast Timefold is changing this visit list. So this visit list inside Santa, it will keep changing these around, and it's doing that at a speed of 9,230 per second. So let's have a look back, and you can see that it has, in fact, oh, that's one I just added. It has, in fact, found the shortest solution. So let's just, for sake of fun, add a few locations. Let's solve it again. And there we go. It has found a new solution. And let's try to see if we can break it a little bit by putting them close together. Hop, solve. Oh, there we go. So it keeps finding the best solution. So that's it. So we have gone through everything. We have visualized everything. We have shown we've gone through our to-do list. We've managed to minimize the travel time for Santa. There's a few things we could do extra, like adding a bunch more locations and let Timefold solve it in that way. But I'm not going to do that in this video. Maybe for a next video. So we've set up our project, modeled our domain with some simple pojos and adding some annotations. We've added our constraints, which is basically 1. We want to minimize travel time, but you can see that you could add some more constraints here. We've exposed it through a REST API, injected the solver, and then we've, of course, visualized it. So that was it. We've gone through our to-do list. This project is finished. We could easily add some more stuff, but that will be for another video. And there you have it, folks. We've helped Santa find a much more efficient route, and sharing every gift is delivered right on time. We hope you've enjoyed this little peek behind the curtain of Santa's high-tech operations. All code we've written here is available on GitHub. If you want to learn more about Timefold Solver, check out our documentation, our YouTube channel, or try any of the other examples in our Quick Start repository. Until next time, and to all of you, a very Merry Christmas and a Happy New Year.